Welcome to today's lesson. So today we not only start our new unit, but we get into the second half of our course, which is all about vectors. So Unit 5 is all on vectors. We are on Lesson 1. We're going to start off with geometric vectors. Let's start off with an introduction to vectors. So not all physical quantities can be expressed by a magnitude alone. Let's take, for instance, gravitational pull. It has a magnitude, but it also has a downward direction. A pilot needs to set both the speed and the direction of flight. Let's go through a bit of terminology. So a scalar is a quantity that describes magnitude or the size, with or without units. It does not include direction. Whereas a vector is a magnitude quantity that has both magnitude and direction. Let's take, for instance, this maze. If you were guiding me through this maze and I had a blindfold, and you had to tell me the direction in which to go, okay, not only would you need to tell me how far, but you would also need to know, I would also need to know what direction I needed to go. So in this case, each leg of the maze would represent a vector because it has both a magnitude and direction. So how are vectors represented? So in words, a vector can be represented by stating its magnitude. So in this case, we have this vector that is represented by this arrow, by saying 5 kilometers at an angle of 30 degrees to the horizontal. So not only do you want to specify the size, but you are specifying in which direction. So in this case, we're saying the degrees, and we have a reference point. In this case, again, is the horizontal. We can also represent it in a diagram as a geometric vector. Again, representing the vector as a straight line and an arrow, writing its magnitude and then its angle with relation to the horizontal. So in symbols, we can represent a vector using the endpoints of the arrow. So in this case here, I'm saying that vector AB, so the vector AB, and the arrow would represent the positive direction. So we're starting at point A, which is the initial point of the vector, the tail, and ending at point B, which is the end point of the vector, the tip. In some cases, we would just simply represent a vector as just a single letter, so V, with an arrow. So a vector has a magnitude. Okay, so the magnitude is the size of its vector, and we use these lines that look like absolute values in order to represent the magnitude of the vector. So in vectors, we will also be studying compass bearing questions. Okay, so we can represent a compass bearing by true bearing, which is a compass measurement starting from north in a clockwise direction, or sometimes called azimuth bearing. True bearings are expressed as 3-digit numbers, including the leading 0. Due north has a bearing of 0, 0, 0 degrees, and, for example, 0, 5, 0 degrees has an angle of 50 degrees in a clockwise direction from due north. So for simplicity, we will use the word bearing to refer to as true bearing. A quadrant bearing always has 3 components: the direction it is measured from, in this case north, the angle, 45 degrees, and the direction towards which it is measured, west. So in this example, we would read this as 45 degrees west of north. All quadrant bearings are referenced from north or south, not from west or east. Let's look at this example. So we want to write true bearing of 150 degrees as quadrant bearing. So here we have a quick sketch of a vector that would represent, in true bearing, 150 degrees. So when writing a quadrant bearing, we have to choose an angle that is less than 90 degrees, so between 0 and 90. So upon observation, you might want to just take it from here. However, it's going to be an angle that's larger than 90. So I would actually reference it from south. So this angle in between south and this line here is 40 degrees. So the way you would write this out would be south of 40 degrees west. So let's move on where you have a couple more terms to go through. We're going to talk about parallel vectors. Parallel vectors have the same or opposite direction, but not necessarily the same magnitude. For instance, in trapezoid PQRS, we can see that the vector PQ is parallel to the vector RS, and that PQ is also parallel to SR. Equivalent vectors have the same magnitude and the same direction. The location of the vectors does not matter, so we can actually move vectors around. Opposite vectors have the same magnitude but the opposite direction. Again, location doesn't matter. Looking at our parallelogram below of A, B, C, D, the opposite vector AB is written as negative AB. Let's look at the parallelogram ABC a little bit further and try and list the vectors that are either equivalent or opposite. Okay, first let's take a look at the vector AB. Okay, so a vector, remember, equivalent vector has the same direction and magnitude. Okay, so these lines obviously mean that they're parallel, so that means that the vector DC, so if we said A to B, we also have to say D to C because that would mean it's the same direction. And D, C, okay? Let's next take a look at B to C. We can say B to C and same direction and magnitude, so that would be A to D. B, C, and A, B, C, A, D, A, D, right? Okay, and then we have, let's do B, A. Okay, then we could just say the opposites of those would be NBC or CD. Okay, and then lastly we can go C, B, and D, A. Okay, this is more just writing out the vectors and words. We can also just write this as A, B is equal to DC, and that would give us a vector equation. Okay, and I'm just going to do these for a few, but I think you get the idea. AD. Okay. Let's go on to opposite vectors. So AB and I'll just do one of these, and so we'll further write the vector equation. So AD, remember they're opposite, same magnitude, opposite direction. So AB and CD. So AB is equal to the negative of CD. Okay, let's do another one. Let's go BA, then we'll just do the opposite. BA is equal to the negative of DC. Okay, and let's do B. We can do BC. BC is opposite to, if we said BC, be DA. Okay, and are we missing one here? AD. It's AD, then it's equal to the negative AD, so CB. There we go. So one last thing that we need to do today is to check our learning. Looking at this, we have here, okay, and that represents, and you're going to make your decision, A, B, C, or D. And the answer is C, is the magnitude of the vector AB. And that concludes our lesson for today, and we'll see you next time.